And okay, so the table of contents, this is some of the things that I'll be going over in this presentation. Again, level 1 is, we're not digging really deep into the IP surveillance part of it. We're just touching the basic foundation of IP surveillance. So the first thing we'll go over is analog versus IP. What are the advantages of using an IP system versus an analog system? We'll also go over advantages of an IP system, cabling for an IP system, DHCP and static IP, the overview of those two, routers and PoE switches we'll briefly touch on, IP cameras. There will be a product overview of our IP camera line. Again, we make a 1.3, 2, and a 3 megapixel IP camera in different flavors. PIRIS overview. We'll be explaining exactly what PIRIS is. ONVIF and PSIA. NVR options as in the product overview of our NVR solution. Throughput. Storage and RAID functionalities will be closing out the presentation. So analog versus IP. Now traditionally everyone has been using analog cameras and connected, and back in the day we were using analog cameras with a switcher, or we were using a multiplexer connected to a VCR, and then in the early 2000s, the DVR was invented, which basically was a digital recorder recording digitally to a hard drive, and had basically a built-in multiplexer. And to date, what we offer now is an IP solution. So the demonstration that we're showing here is a basic analog installation. So there's two boxes there. The outer box is representing a building overview. Within that box is a network closet, or a closet where you're storing your digital recorder. So what you see here is 16 cameras. About 15 of those cameras are external, or outside of the building, facing parking lots, your property, etc. And they're all being home run using coax cable back to a digital recorder. What we're displaying here is that there's a lot of time and effort running wires all the way back, home run back into a digital recorder. And that's what we're demonstrating here. This next slide that you'll see here is the same camera layout, same building. However, what you'll see here is less wiring is being done distance-wise. So what you're seeing is in the four corners of this building, you're basically clustering 4 different locations into a switch, or a PoE switch would be preferably, if you're using PoE cameras. So your distances of cameras is less. Your cable runs is less intensive as far as running it through the infrastructure of the home, or the business, or the building, etc. So what you see here is you see 4 different clusters. So you have a switch, and you have a couple of cameras connected to that switch. You have one on this corner, one on this corner, and one on this corner. And those 4 switches are home run into another PoE switch, which is located in the network closet. And then you have the switch connected to the NVRs, which you see, which is our commander NVR connected to it with one cable. So instead of home running 16 cables all the way back to the infrastructure of the building, you're only really using 4 cables going back into one switch and then connected to an NVR. So that's one way, or one advantage of using an IP system. Another advantage is video analytics. With our our NVRs, we have video analytics built into the NVR. So one analytic that we'll offer is foreign object, people counting, missing object, or camera inclusion. And these are features that are built into the NVR. Another advantage of an IP system is megapixel. With an analog system, what you're using is D1. The highest resolution you can get out of an analog system is D1 or 4CIF resolution, which is 720 by 480. That's standard definition, or SD resolution. The advantages of using an IP system nowadays is that you have megapixel quality, or HD, high definition quality. So megapixel quality allows for a higher definition video quality, allowing you to recognize and identify the object or person. It's 6 times better image quality than D1 and doubles the width and the height of the image, giving you a larger picture. Digital zooming is very, very important. With HD quality pictures, you can do a digital zoom in live or playback, allowing you to capture a detailed image without losing any video quality. If you were to do a digital zoom on an analog camera, what you'll see is a lot of pixelation. But with a megapixel camera, if you wanted to play back and do a digital zoom, you're going to get much more less pixelation. I'm not going to say you're going to completely lose the pixelation, but you'll get, because megapixel quality recordings has much more detail. When you do a digital zoom, you're going to get less pixelation. Being scalable and flexible, utilizing existing network technologies such as a switch or PoE switch and Wi-Fi. This allows you to expand your network infrastructure and add video security surveillance to an existing network infrastructure. Also, you can add additional licenses to an NVR, where with an embedded DVR in the analog world, if you buy a 8-port or 8-channel DVR, you're fixed in with an 8-port DVR. You can't expand any. You would have to buy another unit in order to expand the number of cameras that you wanted to add to the system. NVRs, all you have to do is add licenses. So you have the server, which is your NVR, and you have 8 cameras connected to it, but let's say your customer wanted to add an additional 8 cameras to the system. All you have to do is buy licenses, and it unlocks license keys within the NVR, allowing those cameras to be recognized and recorded. Utilization of existing networks. Basically, an IP system is using what we use today as a hold on one second. Sorry about that. Utilizing existing networks. IP cameras can be utilize the existing network infrastructure, meaning you're using basic data networks, as we do in any business or any residence, and you're using that infrastructure, and you can add cameras and a recording device to it, or an NVR. Allowing a camera to be installed at a remote location, or video can be transmitted via the internet onto a NVR at a centralized location. This is basically saying you don't have to have a physical, you have to have a physical wire connected to a camera, but let's say you have 8 cameras in your building, but you wanted to pull a camera from an offsite which is 10 miles away. All you need to do is assign the camera that's 10 miles away a static IP address, and then you add the static IP address of that camera into the NVR, as long as it has an internet connection or a WAN IP, into the NVR, and it'll allow you to record and view that video from that camera. So you're not locked into a physical space of 16 cameras on a building and that's it. With IP cameras, you can have cameras that you're pulling from anywhere in the world, so you're not limited in that way. Cabling for an IP system. UTP, otherwise known as unshielded twisted pair, Cat5 or Cat6. The wire grades support different speeds. So Cat5, your standard Cat5 is rated at 100 megabits per second. Cat5e is rated at 350 megabits per second. Cat6 is rated at 1,000. Cat6e, 6A, or 7 is rated at 10 gigabits per second, which is kind of rare. Most people will use Cat5e or Cat6, depending on the installation, the lengths, etc. Dynamic hosting, or DHCP, when a network device is connected to a DHCP server, such as a router, it can request to be assigned an IP address that is relevant for that network. Most routers will act as a DHCP server. For example, a computer connected to a router can automatically be assigned an IP address. All current models of EverFocus DVRs and IP cameras support this feature, which is DHCP. Basically, DHCP means if you connect a device to a network that has DHCP enabled, if there's a DHCP server on the network, the DHCP server will assign that device an IP address automatically. The advantages of DHCP: a device set to DHCP can request to be assigned an IP address, just what I just stated before in the last slide. The disadvantage, however, is that the IP address may change for some reason, whether it be you're losing power or the device reboots or something like that. The negative with DHCP is that when it powers back up, or when you regain power, it may capture a different IP address. So initially, when you're installing the system, it may be easier to use DHCP. However, if there is a power outage for some reason and the power restores, you may lose that IP address, meaning that you won't be able to connect to the camera. Two, it's the NVR will not be recording that camera. So that's the negative. With any edge device on the network, it is always recommended, whether it be an NVR, a DVR, or IP camera, anything that is being assigned an IP address, it's always recommended to use a static IP address. And that's what we're getting into next. A static, in any LAN or local area network, a static IP address has to be manually assigned. Now, all of our cameras out of the box, IP cameras out of the box, will be set for DHCP, and that's for the dealers and the integrators out there that are installing our products. It makes it easier for them to plug it in and then find that IP product on the network, and then use our IP utility tool to set the IP address to static. Advantage for static IP address: once an IP address has been assigned, its network settings will not alter. Keeps the same address if the router or the switch is rebooted. The disadvantage for a static IP address: requires basic understanding of network concepts. It's potential address conflicts with other devices on the network. Routers. Most routers support DHCP functionality and can also manage other network-related functions such as port forwarding. Most routers have a built-in switch. this is the reason why they have more than one connection port, as you see on the picture on the bottom right. Large offices or complex networks, a computer is known as a server, which may manage the network and carry out the functionality of a router. Switches. A switch has multiple ports. Numerous network devices can be plugged into a switch. In some cases, to provide more connections to the network, more than one switch can be used, like in the earlier slide where I'm showing you the 4 clustering of switches in the building. Power over Ethernet, otherwise known as PoE. Using a Ethernet port, the PoE switch is able to provide power to a compatible PoE device. A camera or other devices that have the ability to use PoE will not need a separate power supply. A PoE switch uses Cat5e Ethernet cable will give you 100 to 330 feet of power. So on the left-hand side, you'll see a PoE, a picture of a PoE switch connected to a PoE-enabled camera. So through that green cable, which is Cat5 or Cat6, it's transmitting data as well as power to the camera, or data coming from the camera through the switch and the network. On the right-hand side is a non-PoE switch, so you're running still Cat5 or Cat6 cable through the switch, but only data is being transmitted through that Cat5 or Cat6 cable, and a separate power supply is needed to power the camera. Power over Ethernet. When selecting a PoE switch, the user should consider the following. It should provide enough power to the IP cameras, be able to handle network traffic. It is recommended to use a gigabit switch, PoE. EverFocus offers an 8-port switch, which is the part number is ESM308T000D, or a 16-channel port switch, which is ESM316T002R. A managed switch will allow the user to log into the switch and make alterations such as changing the power output per port, monitoring traffic, turning on PoE ports, diagnostics, etc. So they're pretty advanced nowadays with their managed PoE switches, where you can manage the network as well as your cameras. Routers and PoE switches. So specifics on PoE. At the present time, there are 2 standards for devices that are able to provide PoE. So one is 802.3AF, and there's 802.3AT. So the 2 important parts that you want to keep in mind here is the 802.3AF. The power available at the end of that cable to the edge device is 12.95 watts. So at the camera end, this is what you want to be concerned with, this underlined bullet point here. The 802.3AT at the edge device at the end of that cable is giving the camera 25.4 watts. So these are the 2 main specs that you want to be concerned with when picking out a PoE switch. Router versus switch. Router allows multiple devices to be shared on one internet connection. A switch groups multiple devices together. A switch can be connected to a router to provide more connection ports. Finally, most switches are not providing DHCP. So look at it this way. A router is the manager of the network. It's assigning DHCP addresses. It's assigning static IP. It's not assigning static IP addresses, but it's allowing you to choose from a pool of static IP addresses or IP addresses that you can assign the edge device like a camera. The switch is basically allowing you to bundle multiple cameras and connect them into the switch. So next we're going to talk about some of our megapixel cameras, megapixel IP cameras. Megapixel cameras can be used, useful tool. A single camera can be used to provide a higher resolution image and cover greater field of view. Due to higher number of pixels, digital zoom for megapixel cameras can provide more detail in comparison to a standard resolution camera. Even though you may zoom in digitally, you still record the entire image. So you can do a digital zoom on a camera or multiple cameras, but however, when you're doing the digital zoom, you're still recording that megapixel camera in the main field of view that you've originally set it for. So what you're seeing here is a 2 megapixel EDN bullet camera looking at our loading dock as well as some of our parking lot. This camera is a EDN 3260. What we're pointing out here is take a look at the truck. On the left-hand side, you see the print that says line. The next slide here, you will see 2x zoom in high definition at the top, and on the bottom, you'll see a 4x zoom in standard definition. So you'll see that there is less pixelation on the high definition camera because it has more detail, has more information, it has more pixels to display during the 4x zoom, giving you a cleaner, less pixelated image when you're doing a digital zoom. So that's probably, for me, it's the number one advantage of using a megapixel camera. Defining field of view. For example, in this image below, a 2 megapixel camera can replace 2 standard resolution cameras. So on the left-hand side, you have a standard definition camera at 720 by 480 resolution. Now you see it's still a pretty good picture quality. However, if you look on your right-hand side, you have a 2 megapixel camera set at 1920 by 1080 resolution. So if you look at the camera's width here, as well as the height, the width is probably more noticeable. You'll see that this tree on the left-hand side of the 2 megapixel camera is in the picture, while in the standard definition image on the left-hand side, the camera or the tree is missing. So that's an advantage of using megapixel cameras, as well as you're getting a bigger picture. Defining field of view. Again, here is another demonstration of standard definition versus high definition. In a confined location, a hallway, small room, or closet, a megapixel camera may not be beneficial to you. Consider the 2 images below. No significant advantages is apparent due to the restrictive space on the field of view. However, you can still benefit using the digital zoom feature on the megapixel camera. So basically what we're saying here is that in a confined space where it's more narrow, the wider field of view may not be beneficial in this type of scenario. But doing a digital zoom, it will still be an advantage using the megapixel camera in this situation. Product overview. So here is our IP camera lineup. So you have your EAN line is representing a box camera. An EDN is representing an indoor dome camera. And the EHN series is the ruggedized or rugged dome, outdoor dome cameras. EZN is representing the bullet cameras, and the EPN is representing the pan-tilt zoom cameras. Some common features of the IP Plus series. All the cameras that we just showed in the previous slide are part of the Plus series camera lineup from EverFocus. Dual voltage PoE or 12 volts DC except for the PTZ cameras. All the cameras are equipped with a 10/100 LAN port. EverFocus provides a free DDNS service or supports DDNS using our DDNS server. Analog BNC output for focusing the camera with your little test monitor instead of having two people, one at the server end and one up on the ladder trying to focus it. You can use the BNC output port to focus the camera on at the location. Multiple streams supported, so you can configure each camera to choose a specific compression type. You can set the camera to stream at a certain frame per second. You can set it to a specific picture quality. Bandwidth control, fixed with an upper limit. You can set a high limit value or a low limit value on the bandwidth that the camera needs to stream out to the network. Or you can set it to a variable. Alarm inputs and output triggers, so you can set triggers, contact closures on the camera itself. Email on alarm. You can send an email out if there's motion or an alarm contact relay. Two-way audio is supported with all of our cameras. It has a line level input and output. All the cameras support a SD card for local recording. Instant FTP upload of alarm events. You can have events posted to an FTP server if you have an FTP server available to you. Up to 10 connection up to 10 connected clients with controllable rights. ONVIF and PSIA supported, and all the cameras are CE, FCC compliant. The EAN series, or the box camera series, we offer this in a 1.3, 2, and a 3 megapixel camera. All of the box cameras will start with an EAN as a prefix, and then the 31 obviously is 1.3. The 3220 is 2 megapixels, and then the 3300 is a 3 megapixel camera. These are typically used indoors, but you could use it on an outdoor application if you use an outdoor housing like our FH7153HB housing for box cameras. A megapixel lens is required to get the best picture quality out of a megapixel camera. You want to use a megapixel lens, giving you the best optics and best picture quality. Next is our EHN series. The EHN series is our Rugged Dome series camera. This camera also has wide dynamic. It has a very good day-night feature, and also has a IR illuminators which you can turn on or off if you want to use the IRs. Some people don't like the IR reflection that you may get depending on the environment that the camera is plugged into, so we give you the option to turn off those IRs. These cameras also have wide dynamic range built into it as well, eliminating the washed out or the blurring effect that you get when cameras are looking at a very bright light. The camera is a 3-axis true day night. As I mentioned, it's 3 to 9 millimeters with a P-iris lens. It's vandal proof, IK10 rating. It's IP68 with a temperature or operating range of -40 to 131 Fahrenheit. Here are some examples. The EHN series is probably one of my favorite cameras only because of the installation. As you can see from some of these demonstrations, the camera comes in 3 pieces. Well, you install it in 3 pieces, I should say. The first step would be installing this plate, this mounting plate. So you would mount this camera either to the wall, and then you'll also see multiple holes here. This will accommodate the holes for electrical boxes or junction boxes, where you can stuff the wires into, or you can simply mount it to the wall as you see here. And then the dome, the outer dome, will mount to these 4 holes or 4 posts that you see here. And those posts are not inside of the housing, but it's on the exterior of the housing, eliminating any water or any moisture that can get into the internals of the dome itself, eliminating moisture to be built up inside the housing itself. And then the third piece is the camera itself. So the camera has 2 screws that you lock into place inside of the dome. And then finally you would mount the shell or the outer dome cover on the top of that. This is demonstrating this picture here on the top left corner. It comes with this little grommet, which is where you run your wires through, and then you screw it down, and it allows for a tight seal, not allowing any moisture to get into the inside of the camera. Or if you want to eliminate this grommet altogether, you could use you could wire conduit directly into the side of the dome camera, or on the back. The EDN series is our indoor dome camera. Again, it comes in a 1.3, 2, and a 3 megapixel. The 1.3 and the 2 megapixel wide dynamic. Basically using the same foundation as the EHN camera. However, it's using not a non-ruggedized housing. It's using more of an indoor housing, although it is still a vandal-resistant camera. It is a 3-axis camera. It's using the 3 to 9 millimeter P-iris lens, true day nights, IP66 rated. You could also mount it flush onto a wall or a ceiling, or you can surface mount it. Next is the EDN Series bullet camera. Again, comes in a 1.3, a 2, and a 3 megapixel. The 1.3 and the 2 megapixel come in a wide dynamic range. Again, this outdoor bullet camera can accommodate to a 4-inch electrical box. So this comes with an easy mounting plate as well, which you see here. This ring on the bottom is the mounting plate. So what you would do is you mount this plate to the junction box or the wall, and it's a standard hole pattern which fits the junction box, screws right into the junction box, and then you can stuff the wires into the junction box and then mount the base plate of the camera onto this mounting plate. It's an IR camera, and you can turn those on or off as well in the settings of the camera. It has a 131 feet IR range. This camera has a lens of a 2.8 to 10 millimeter motorized lens. So this one you do not have to fidget around with the lens while you're on the ladder mounting it. You can just mount it, plug it in, leave it up there, and then come back to the computer that's on the network or the NVR that's on the network. And because it has a motorized lens, you can focus the camera remotely rather than doing it on the ladder. It is a vandal-resistant camera, IP66 rated, and again, its operating range is -40 to 131 Fahrenheit. Our PTZ camera, or the EPN 4220, is a 2 megapixel camera. Also has wide dynamic range. This is also available in an indoor version. The lens that we're using is a 4.7 to 94 millimeter lens. The optics are great on it. You have a 20 times optical zoom and you have a 10 times digital zoom. True day night, slow shutter option, digital auto flip. You can program auto panning, set tours, has an alarm trigger, normally open or normally closed contacts that you can wire to a door or magnets or whatever you want. Easy installation. It has the snap and lock dome, so you mount the outer dome itself, and then you take the camera and you put it in, snap it in. It has 2 locks on each side. It provides 24 AC. A 24 AC power supply is provided with it, or you can use your own power supply if you wanted to. It's IP66, again, -40 to 122 Fahrenheit. So next I'm going to briefly talk about P-Iris, other known as powered iris. First, I'd like to explain the depth of field, other known as DOF. DOF is the distance between the nearest and the farthest object in the scene that appears acceptable or sharp in an image. So once a camera has been focused, usually the image in the background or the foreground will be slightly out of focus, and that's how it is in traditional cameras. However, with a P-Iris camera or P-Iris lens, everything will be in focus: the foreground, the background, and the main target that you're trying to focus on. The next few slides will demonstrate that. So let's go to the next slide. So in this slide, what you'll see here is an example of the foreground is in focus, where you see the telephone and this brochure, but the background is out of focus. So the brochure up at the top right, and anything outside of this window is slightly out of focus. This next example shows the background is in focus, but the foreground is out of focus. So you'll see the trees outside, more defined. The brochure up at the top is more defined. These banners or posters on the wall or window are more defined. However, the brochure and this telephone is out of focus. So finally, what P-Iris does will allow you to get a sharp, clean, detailed image in your foreground and your background. So with this image, you'll see that the foreground, telephone, brochure, and then your background, outside trees, posters, top brochure, is all in focus. So that's basically what P-Iris is in a nutshell. It allows you to focus in on the foreground and the background. Next, we're going to talk about multi-stream. So multi-stream gives you the user the option to stream live video in different formats and record video in different formats. So that means the frames per second, or FPSs, the resolution, and the compression. For example, to manage bandwidth, a user could stream live video in a lower resolution and record video in a higher resolution. That allows you to manage your network and your packets on the network a little bit more efficiently. ONVIF and PSIA. In the context of IP camera solutions, ONVIF and PSIA are two different bodies with the same objective of providing standard network video formats. A standardization format will allow the cameras from different manufacturers to function and manage from one NVR or VMS platform. EverFocus Plus series cameras support both ONVIF and PSIA, allowing more flexibility of working with many third-party NVRs or VMS software. So these two organizations are basically trying to tie in the camera vendors and the VMS and NVR manufacturers and creating a unified platform or protocol that says if you use ONVIF or PSIA, this camera will work with this NVR or recording platform, and you can interchange this camera with this platform or this platform with another manufacturer. That's basically all it is. It's a industry standard of a protocol allowing multiple devices to talk to each other. IP utility. So the IP utility comes equipped with all of our IP devices. It's a tool or an executable installed on a computer that you can install on a computer that's on the same network as your cameras, and once you click on the button Find Devices, it'll find all the EverFocus IP devices on your network. And from here, what you could do is you can do anything from setting IP addresses to the cameras. You can do firmware upgrades. You can save camera configurations. It's a tool that allows you to manage your cameras. NVR options. So what you see here is some of our NVR devices. At the top left corner, you have our Elite, which is the more basic entry-level NVR. You have the Commander, which is more of our enterprise-level NVR. And then you have our ENVS series, which comes you can purchase it in just the software and add licenses to it, or you can have a server. We can build you a server and load the software and licenses on the server for you, which is more of a Windows-based platform. The Elite Series NVR, available in a 4-channel, upgradable to 16, 4-channel device that can be upgraded to 16. It maxes out at 16 channels, so if you want anything more than 16, you'll have to upgrade to either the ENVS or the Commander series. The maximum throughput on this camera is, the maximum throughput on this NVR is 80 megabits per second. Has 4 hard drive bays, which you can set for either RAID 0, 1, 5, 10 functionality. It's a very compact unit, so it's probably as big as a shoebox. It's very small, compact. Has intelligent searches, so you can do searches on any of the analytics that we spoke about earlier in the presentation. You can add a POS or point of sale accessory to it, so you can talk to different cash registers or POS devices that are on the network, capture that metadata, and there you can do searches on that metadata, and it'll have a text overlay of video in the background, and then you have the text from a POS in the foreground. The Commander series is more of, so the Elite and the Commander are both Linux embedded devices. The Commander series is more of our enterprise level device. It's from the picture on the bottom right, you'll see that it's more of a blade server. It's a 19-inch rack mountable 1U server. Supports 4 channels all the way up to 64 channels. Optimal throughput on this unit is 150 megabits per second. Maximum is 250 megabits per second. The unit has a VGA output port for local support. It supports Windows and Mac's compatibility to connect to it, so you could connect a Mac or a Windows-based PC to it and configure it and set it up. Has a stitching feature, which is pretty cool, so you can take multiple cameras, stitch them together to make them look like one big camera. In some cases, people will stitch up to 10 cameras together and get like a 360 panoramic view, and then you can scroll around left to right with that picture. Digital and optical PTZs, pop-up event playback, centralized EMAP. You can add an EMAP to it, creating a map and then adding icons to the map of cameras. It does support RAID 0, 1, 5, and 10. And then it also has intelligent motion, event search and playback for subject of interest searches. And that is it on the Commander. Lastly, the ENVS NVR, software-based NVR supports up to 4 to 64 cameras. Again, the ENVS is a Windows-based application designed for, the ENVS is more displayed, designed for local display, meaning you can connect to it or connect a VGA monitor to it because it has a strong video card on it. And you can connect multiple monitors to it if you wanted to, using the video card on the back has an HDMI, a DVI, and a VGA output, so you can utilize all 3 outputs if you wanted to. Remote input and output solution and camera input-output integration. Audio and video synchronization, basic analytics, counting. There's a counting application, missing or foreign object detection. And it also supports POS for point-of-sale integration. The ENVS does support the EverFocus access control integration as well, so you can connect and integrate our access control device with the ENVS. And then, again, playback with intelligent searches like general motion, missing object, foreign object, etc. And then you can also take snapshots from recording bitmaps or JPEG formats to save or to print. Network configuration is next on the list. IP surveillance cameras will generally utilize large bandwidth network traffic. An existing local network structure may not be able to manage daily business traffic and IP camera data streaming simultaneously. And basically what that means is it's not recommended to put video surveillance IP cameras on an existing network. As you know, video files tend to be larger, especially nowadays with Megapixel, are going to be large file formats that is running over the network. So you don't want to compromise your data infrastructure where you're getting your emails, you're looking at going to the internet, you're sending files to the file server. You don't want to compromise your data structure and with your video CCTV network. You want to keep those completely separate. When considering an IP camera solution, it may be advised to create a separate network for an IP camera. The Commander and the Elite have dual network ports. This gives an option of connecting one port to a standalone network, specifying and creating for an IP camera. The second port can be connected to an existing network, allowing the user to access the NVR from a local network. That's what you're seeing from this diagram here. You're seeing the back of the Commander, and on the top you have your data network where you're running your email, you have your file servers, you're going to the internet, etc. You want to keep this LAN completely separate from this LAN. The bottom LAN is your video network. And the way that the Commander and the Elite series does that is using two separate network cards on the server itself. So one network port would connect to the data, and then the second network port allows you to connect to the video CCTV side, and that reduces the bandwidth traffic between both LANs. Next, we're going to talk about network hops. Hops, this is a terminology in networking to describe the number of switches or routers a data packet has to pass through to reach its final destination. Consider the example below. The data transmitted from the IP camera has to go through a single switch to reach the NVR. This is one hop. So you have the camera into a switch to the NVR. That's one hop. This switch is considered one hop. In this example, the data stream from the IP camera has to pass through two switches. This would be considered two hops. So camera, switch 1, jumps over to switch 2, and then jumps over to the NVR. That's considered two hops. The next example is three hops. So you have camera, switch 1, switch 2, switch 3, and then to the NVR. That's considered three hops. The more hops that the camera has to go through, or the data has to go through, the more latency the video you're going to receive on the back end. You're going to get less latency and much better video quality and better refresh rate on the video when viewing it live if you had a straight cable going directly into the NVR, or if you're going only into one switch rather than multiple switches, reducing the hops. So next we're going to talk about throughput. Throughput is the DVR's performance determined by its recording resolution and frame rate. In comparison, an NVR's performance is determined by its throughput. Throughput is measured by megabits per second. A high throughput value will allow an NVR to record more information. Megapixel cameras transmit more data than a standard definition camera. Therefore, an NVR with high throughput values will be able to better support more megapixel cameras. The amount of information that is transmitted by an IP camera is measured by megabits per second. The value in the table, which is in the next slide, approximates bandwidth used by an IP camera and can be used as a basic guide to determine the suitable NVR for the application. So what we took here is from our online calculator. We just took some of these values to give you some examples. So if you look here on the left-hand side, you have the different megapixel cameras that can be offered throughout the industry. Right now, we use a 1.3, 2, 3, and a 5 megapixel. Across the top, what you'll have is 30 frames per second, 15 frames per second, or 10 frames per second. And these are the values cross-haired here. So if you got 1.3 megapixel camera at 30 frames per second, it's 7.28. Or if you have a 2 megapixel camera at 15 frames per second, you have 8.14. So here's example 1. So example 1 would be determining the max bandwidth of 4 cameras at a resolution of 1.3 megapixel at 30 frames per second. So here's the math. So you would take from, if you're using the chart that I just showed you, you would take 1.3 megapixels at 30 frames per second, which is 7.28 times 4 cameras. That gives you 29.12 megabits per second total bandwidth. So in this application, I would probably recommend using an Elite Series NVR because it offers 80 megabits per second. So that would be a suitable choice there. Example number 2. We're going to use 16 cameras at a resolution of 3 megapixels and at 30 frames per second. So we would take 7, utilizing the chart that was in a couple slides back. We would take 17.07 times 16. That equals 273 megabits per second total. Now the Elite is only giving you 80 megabits per second, so this is not a suitable solution for this application. So what do? Well, what you're going to do is you're going to you have a couple of options here. You can reduce the frame rate on the cameras or multiple cameras to get you within that 80 megabits per second to use the Elite. You can use a lower resolution and then recalculate it, and hopefully that'll get you in the 80 megabits per second. Or you can upgrade to the Commander series and use the full resolution and the full frames per second throughout all 16 cameras, and utilize by utilizing the Commander, you're going to get approximately 150 megabits per second all the way up to 250 megabits per second if you're using both network cards in the unit. Next, we're going to talk about storage and RAID functionality. NVRs are compatible with external devices, providing data storage for prolonged periods of time depending on the NVR. It can support FTP or File Transport Protocol, or not NAS for data storage devices. So the FTP, or File Transport Protocol, FTP is used to store data on a remote server. Usually a daily schedule is set up on the NVR to copy data from the drive to the FTP device. And then a network attached storage is basically a device or a large hard drive that is on the network. You're assigning the network attached device an IP address as well, and you're basically saying, look for this network attached device and I want to dump data to this device as well, giving you additional storage or backup. Next, we're going to talk about redundancy. Modern NVR support data redundancy such as RAID 1 and 5, which can minimize the chances of data loss due to unforeseen circumstances such as damaged hard drives. RAID refers to redundant array of independent disks. There are various types of RAID supported by today's NVRs, such as RAID 0, 1, 5, and 10. First, I'll talk about RAID 0, which is not recommended in the CCTV world. It's basically multiple drives. In this example, it's using 4 hard drives, and all 4 hard drives are acting as one. That's not really giving you any redundancy in a network device. So RAID 0 is not recommended in a CCTV application or the applications that we're talking about today. What is recommended is using RAID 1. RAID 1 basically is, and you can look at this diagram on the bottom right, RAID 1 is basically mirroring a drive. So you have 2 drives and data is being recorded on both drives. So you're recording camera 1 through 4 on disk number 1. You're also duplicating or mirroring that information on disk 2. So you have 2 exact copies on 2 separate disks. That's RAID 1. RAID 5 is basically what we call striping. So you're copying and recording data to multiple drives. Typically it's 4 to 5 drives. And the striping comes from because you're striping across. If you look through this diagram on the bottom right, you're taking information and recording information on each individual disk. And this is redundant because if there is information on each disk and one of the disks fails or gets corrupted or crashes, all you have to do is put a new drive in, and that new drive is going to be completely empty. But once you put it into the system, what RAID 5 will allow you to do is take information from the other 3 drives in this scenario, and it'll rebuild that new drive and add all the information that it was missing. So IP solution summary. So we're just going to summarize what we talked about here. In the IP cameras, the selected IP cameras for each install location must be suitable. The camera must be compatible of handling physical environments and provide the field of view and the image quality that is desired. Stable network is also important. A stable network infrastructure is essential. This requires the use of any good quality switches and Cat5 or Cat6 cables with minimal number of hops. If a PoE switch is considered, it must be able to provide enough power to all the cameras connected to it. So that's when I was saying the 2 terms, the 802.AT and AF, those are 2 voltage readings that you want to be aware of when picking a PoE switch. NVRs, the NVR should be able to manage a number of multiple cameras connected to it and have a suitable storage capability. Sometimes the user may need to consider a higher spec NVR that can be updated with licenses and support future camera installs. And that's basically it. What I'll do next is I'll unmute anyone, and if anyone has any questions, they can go ahead and ask me at this time.
Okay. Bueno, estoy aquí en una conferencia.
So if anyone had any questions, I can try to answer them for you now. There's a lot of background noise that I'm hearing there, so I just muted everyone. I'll try to see if there's any questions on the chat list here. Margarita asked if this presentation will be downloadable from our website. What we'll do is that the dealer partner administrator will review everyone that attended the class today and will email you a copy of this. And then we'll also give you information on any tests, the test for level 1. Let's see. Do you offer training manuals or hands-on training classes? This is from Stephen Moore. So this course is level 1. We'll have a level 2, which is more getting into the configuration of NVRs and IP cameras and picking different devices for your applications. That's what level 2 is about. Level 3 is more hands-on. Level 3 will be in different locations throughout the country, and we'll have our course administrator give you a hands-on lab where you'll physically install our devices together, and you can purchase our demo equipment at the class. Actually, you will have to purchase some of our equipment at a discounted price through the distributor. And then you'll get your hands-on class, and then you'll have a certification test. And those are all the questions that I see here. Everybody, I believe everyone has my email address, so if you have any questions, feel free to send me an email, and then you will be hearing from us shortly with this presentation sent to you in a PDF format, and then also information on when and how you can take the certification level 1 test to be certified under level 1. Then you can move on to level 2 and level 3. So that concludes the presentation, and hope everyone enjoyed it and have a good day. Thank you.